Hello guys, hope you are fine. This is Mohammad Haris from Telecom Department 21TE37. So today I am making a recording a video of my lab report one of submitted to my lab attendant engineer Dr. Jamil. So I've also created in this video I'm going to explain the different codes and tasks that are given, and I also have created an AI video to explain what is digital signal processing, so the people get basic idea okay, what we are studying about. So this is the video.
Imagine a world where your favorite music tracks are just a cacophony of noise, or the vibrant images on your screens are mere pixelated chaos. That's a world without digital signal processing. This sophisticated technology is the unsung hero behind our digital world, quietly working in the background to make our lives more enjoyable and efficient. Digital signal processing, or DSP for short, is a method used to manipulate signals, like sound, images, and temperature, in order to modify or improve them. This process transforms real-world signals into digital form and manipulates them in ways that are simply not possible in the analog world. The process of digital signal processing begins with signal acquisition. This is the step where we gather raw, real-world data like sound, light, or heat. These signals are continuous and therefore need to be converted into a digital format that our computers can understand. The second step is signal conversion. Here, the continuous signals captured are transformed into digital signals. This is achieved through a process known as sampling, where we take snapshots of the signal at regular intervals. By doing so, we can convert the continuous signal into a series of discrete values. Once we have the digital signal, the next step is signal processing. This involves manipulating the digital signal to enhance its features or extract useful information. Various algorithms and mathematical functions are used to accomplish this. For example, noise reduction in audio signals or image enhancement in picture processing. The final step in the digital signal processing journey is signal reconstruction. Here, the processed digital signal is converted back into an analog signal that can be used in the real world. This could be the sound coming out of your speakers or the image displayed on your screen. But why does digital signal processing matter? Why should we care about this complex process happening behind the scenes? Well, without it, our modern world simply wouldn't function as it does. Every time you make a phone call, listen to music, take a photo, or watch a video, you're benefiting from digital signal processing. It's the technology that allows us to live in a digital world, and it's only going to become more important as we continue to push the boundaries of what's possible with digital technology. In summary, digital signal processing is a four-step process: signal acquisition, signal conversion, signal processing, and signal reconstruction. It's the magic behind the scenes that transforms raw, real-world data into something our digital devices can understand and manipulate. It's the technology that makes our digital world possible. And it's a field that's constantly evolving and expanding. So, the next time you're jamming to your favorite tunes, remember the complex process that made it all possible. That's the power of digital signal processing. Without it, our digital world would be a very different place.
The lab objective of this lab is to perform explain an importance of digital data in context of sort, search, store, and transmit, how to plot signals, write scripts in MATLAB, Octave, and creating MATLAB functions. The first task is in the context of digital signal processing, elucidate the essence and intricacies of stipulated within the term of digital. So in the first task, they have asked to elucidating the essence of the digital in signal processing. In digital signal processing, the term digital refers to the representation of signal, typically an analog in nature, in discrete form using binary numbers 0s and 1s. This process involves converting continuous time signal into discrete time signal through a process called sampling. The essence of digital in DSP lies in its ability to manipulate signals in the digital domain, offering advantages such as precision, reproducibility, and ease of processing. Key intricacies stipulated within the term digital in describe. So basically in digital signal processing, the digital word means that we are converting our signal from continuous time to digital form. Through this process we get more effective and precise signal. The intricacies that are discussed here is discretization, quantization, processing algorithm, binary representation, and signal reconstructions. So basically, desynchronization means that signals allow for precise representation of signal. The quantization represents the quantizing the errors and affecting the signal process. And processing algorithms such as filtering and modulation and demodulation are used in different signal processing. Binary representation helps in the efficient transmission of storage and signals, and signal reconstructive that allows the signal to be reconstructed into its original form, such as continuous signal and speakers and etc. The task tools ask us choice between linear search and binary search in DSP application. The linear search involves sequentially checking each element in a list until the desired element is found or the end of the list is reached. In DSP, linear search can be used for tasks such as finding specific values in an array of sampled data points. Linear search has a time complexity O(n), where n is the number of the element. In binary search, the binary search is more efficient search of algorithm that operates on a sorted array by repeatedly dividing the search intervals in half. In DSP application, binary search can be utilized when the data is sorted, such as in the fast Fourier transforms algorithms. Binary search has a time complexity O log n, making it significantly faster than the linear search in a larger data set. The relationship between the digital data and sorting. Digital data in DSP applications often needs to be sorted in an efficient process. So we need an efficient process such as fast Fourier transform. For that purpose, we use the binary search. In this, the data proficiency of the efficiency is effective. And in summary, the choice between the linear and binary search in DSP application showcases the importance of sorting and digital data processing and highlighting the application for data processing and efficiency. The task 3 involves strategies to enhance data transmission efficiency in the domain of digital data. The strategies that are used in the domain are comprehension technique. In compression technique, the signal is comprehended for that for such as in JPG and or MP3 audio form. And error detection and correction code are used for cycling redundancy check, and Hamming codes are used for error detection. Multiplexing is used for time division multiplexing and frequency division multiplexing. Channel coding and modulation are used for quadrature amplitude modulation and phase shift keying. And packetization is used for TSP and IP applications, and adaptive transmission are used for coding AMC. And quality of the management ensures the digital data. Our next task, first 3 tasks are performed, and our 4th task is plotting sinusoid in MATLAB. To plot a sinusoid in MATLAB, first of all, we will consider this code. The code is T is equal to, for plotting the signals, first we use this code, and this output has given. As you can see, we are getting the same output over here. Task 5 is adding title, labels and axis bond to the signal. As you can see, we are given this signal and we need to add title and axis bond. In MATLAB, we are going to add, and as you can see in here, we have added 0.2 and changed the axis. You can see the result of changing the axis is that we can have a more complicated and more perspective view of the signal. In next task, it is asked to plotting signals in a same frequency. As you can see, we are given the code with the signal that having a same frequency. Plotting the same figures and amplitude will get this following result. As you can see, adding the same will increase its amplitude, and we will have a more complicated signal. In our next task, plotting without connecting the dot. First of all, we are going to in MATLAB, and we're gonna give the time domains and frequencies of this, and we're not going to connect these dots. As we can see, there is no dot connected in our signal. Next is using a plot rand. When we use we have defined a function plot rand, and by asking it in the command line, and by running it we will get our random mean of random uniform. By defining a function and by writing in the command line, we can get the following function. And same when we write a function, we will get this following output. In our next task, it is asked to perform in task number 8 we are asked in task number 9. In task 9, 10, 11, 12 and 13 we are asked to define a function my min, my max and my average and my sort. So in this task I have written a code that is going to use this function, and for min function we're simply use this function. For max, for average and for sort and for reverse I have considered this function, and when I use this function I will get this following output. As you can see here, my minimum value is given, my maximum value is given, my average value is given, my sorted vector and my reverse vector is also given. In our next task, it is asked so you can draw multiple plots in one figure using subplot. In this MATLAB code, we are going to use the subplot MATLAB command to having different plots in our command. As you can see, by using this we can have different kinds of subplots in our as you can see here. You can see here that by using the subplot command we can have two signals in one figures. In task 15 we are going to perform a function that I've made a function that was given a task win for, that is going to give us 4 signals of 1 by 4. As we can see, for example, for sine function, for sine signal, for cos, for exponential and log. So we're getting this following output. As you can see here, we can get a sine and cos signal and exponential signal and a log signal. So this was my lab 1 of digital signal processing. Hope you have understood that. Thank you.